The Titan submarine, built by the company OceanGate, exploded inward on June 18, 2023 while descending towards Titanic. In the accident, 5 people inside the submarine lost their lives. So how could this accident have occurred? It is very likely that they first found the huge titanium block door as debris on the sonar. By the way, they probably died suddenly, not slowly. Suddenly the structural integrity of the pressure tank was lost, that is, just as an explosion is a sudden explosion. This is a sudden collapse, it suddenly explodes inside. NASA and the University of Washington start developing the project at the conceptual stage. The first development aim is not to make tourism, but to make remote-controlled exploration, but the OceanGate company offers tourism services to rich people to fund the project, otherwise the money is not enough. After the concept design stage, subcontractor engineering companies are involved in the project. But engineers who have already worked on this project say that in order to save maximum money, they worked with the cheapest possible parts, off-shelf, such as the control being a game handle, but the most fatal mistake was made in mechanical engineering. When designing submarines, airplanes, rockets, helicopters, etc., mechanical design and strength are always based on worst-case scenarios. For example, I am producing a submarine. It is assumed that the cabin material of this submarine is damaged, corroded, hit left and right before production, exposed to the heaviest loads in the sea, and despite all of these events, it remains intact in one piece. Thanks to this logic, mechanical-based accidents in aviation in the last 30 years have had the lowest share among the causes of accidents. Usually accidents occur for other reasons. Now these OceanGate friends have tested the Titan for a depth of 1,300 meters and had it approved by third-party authority organizations, but the Titanic is 4,000 meters below. The assumption that it will withstand 4,000 meters is based only on computer simulations. However, if the container of this Titan is designed with carbon fiber composite, with the correct orientation of carbon fiber against certain directional pressures such as hydrostatic pressure underneath, it provides very high strength with low weight. It is the basic material of aviation today. But it is difficult to design and simulate because its mechanics are complex. It can lose its function in the slightest fiber matrix defect. If you immerse this material to 3 times the certification depth without pressure testing, in the slightest fiber, matrix separation or delamination, layer slippage, you will lose the cabin structure and get water inside. Then when you lose the internal pressure, the external pressure will press directly and collapse you inside. So why did the submarine fail now, when it had successfully landed on Titanic before? Although the cabin was certified for 1,300 meters, the design, calculations and simulations were made to withstand 4,000 meters, but the full-scale static strength, max load as applied at once, and high, low repetitive fatigue tests of the cabin were not conducted. They are complex tests that can take a very long time, but they are mandatory. For this reason, many engineers from the sector sent warning emails to the company, even saying that this is not the way to do it. Therefore, even though it dived successfully a few times and saved its static strength, it may have been damaged at the polymer matrix fiber interaction point before or during its last dive. I don't think it was fatigue. It didn't dive for so many hours before. This is roughly the reason.